Okay, so next week, we are going to solve multi-step equations. So you just took a quiz and you showed me that you can do one-step and two-step equations. Now, next week, we're going to do multi-step. So it's going to be more than 2 steps. So we need to review today combining like terms and tomorrow the distribution property. Both things, I believe, are a review from last year. Maybe. Okay. So hopefully this will be more of a relaxing lesson. Okay. So here we go. First, let's just talk about the difference between variables and constants. Okay. So variables are a term with a variable. So a variable is a letter. Okay. So variable terms have letters. Constant terms don't have letters. Okay. So I am going to take my pink marker here, and I'm going to put a box around anything that has a letter. Okay. Now, when I do this, I do need to include the sign in front of it, whether there's addition or subtraction. Okay. Okay. So our variable terms are 14x minus 2x and minus 5x. Those are our variable terms. Me just boxing those just like brought it all back from last year, huh?
Yeah. I remember this box.
Okay. Okay. Now, when we talk about coefficients, we're talking about the number in front of the variable. So like 14 is a coefficient because it's the number in front of x. -2 is a coefficient because it's the number in front of x. And our other one would be -5. It's the number in front of x. Okay. Now, I'm going to put a circle around our constant terms. Okay. 9, 8, and 1 are our constant terms. Okay. Now, if you put a +9, +8, +1, that's fine, but you don't need to because that plus means we're adding a positive number. Okay. But if there's a minus, that does need to stay attached to your number. Okay. Now, eventually we're going to take this example and we're actually going to combine like terms, but let's just practice boxing and circling to identify which ones are variable terms and which ones are constant terms. So I want you to look at this first example right here. 11a, is it a variable or a constant? Variable. And what about +4a? Boring. Okay. Oh, I'm out of terms. Corin, do we have any constants? Thanks, Corin. There aren't any constant terms in that expression. Okay. Now, Bronson, when I talk about coefficients, which numbers are coefficients?
11 and 4.
11 and 4 are coefficients because they're the numbers that are attached to A. Okay, that example was boring. Let's do another, a more exciting example. Judah, you're fine with one? Okay. All right. So I'm going to put a box around anything with a letter. So 3x, I'm going to put a box around. And that +7x, I'm going to put a box around. Okay. Then I'm going to circle anything that doesn't have a letter. So our variable terms are 3x and 7x. Okay. And then our constants are a +6 and a -4. So a +6 and a -4. Okay. Ryan, which ones are our coefficients? Okay, but if I ask you for the coefficient, I only want you to tell me 3 and 7. Okay, you and your elbow partner work on number 3 and 4 for me, and then stop. No?
Like where that was going. I'm gonna shock it out.
I have?
What? Oh, I thought you were doing it. I wouldn't say that to you, my man. Yeah. Well, that is just not, that is just disrespectful. You have to say what about it?
Okay, you're working on 3 and 4. 3 and 4. So what number is in front of K in that one? This one. Like what number is attached to K? We don't write it, but what's there? Oh, 1. So the coefficients. Brady, what are our variable terms in number 3? Okay, whether you say -12m or -12m, same difference, okay, same thing. All right, so then let's just go, I know that's the third thing, but our coefficients for number 3, Bennett, what are our coefficients, Ben?
-12 and +4.
Ariana, what are our constant terms? Number 3.
-3 and 6.
Good. Okay. How about for number 4, Arisa, and what are our variable terms? Oh, do you notice how she did that?
Good job, Arisa. It's a 1.
Okay. Now, is there a 1 written in our example? No, but if there's not a number there, then we assume it's that invisible 1. So our coefficients are 6 and 1. Man, you're a step ahead of me, Arisa. Great. And then Denise, what about our constant terms? Good. Awesome. Okay. All right. So somehow this got like copied a little weird. I need you to turn the page to page 20. To page 20. And we're at the top of the page here. What I want you to do first is go ahead, box the variables and circle the constants. So
Wow.
just that 14x plus 9, you're just circling and boxing and stopping.
I did.
Boxing as in like boxes, not. Okay.
He grubbing. He grubbing.
Okay, I just handed you a green strip of paper. Do you recognize it?
Yes.
No.
Yeah.
It's exactly what the,
Why is it upside down? Oh my God, Jada.
okay, this is what I want you to do. Okay, you are going to cut apart each
Scissors.
of the terms.
I love scissors. You could trust me, I promise.
So,
What did you?
don't touch my stuff.
Oh, her.
So, did you put a box around the plus? Oh, good.
I
You
circled
put a
that.
circle around the +9. So what I want you to do is I want you to cut the 14x up from the +9.
Wait, what? I think so.
And then that +9, I want you to cut it away from the -2x.
What? So we're just cutting them into small pieces.
Oh, you're like cutting them into the pieces that you circle and box.
I'm literally so smart.
Yeah, no, he really.
I hope I got this.
I'm telling him, good job, boy. That was sarcastic. That was so rude.
Okay, so we've got this discussion. We just don't really know when Jada's joking and not.
What? Dude, stop being rude. Good job. Whoa, there's rulers on this? Whoa. No. Good. Oh my God. Oh, where you? Yeah, I know I am. That's a good observation. Thanks, Jada. That's cool. I didn't know they did that.
What?
What?
On the scissors. Our little.
Oh.
Where?
Oh.
Okay, so now what I want you to do is I want you to rearrange your 1, 2, 3, 4, 5, 6 terms to where your x's, like your variable terms, come first, and then your constant terms come second.
I can't tell if my 8's upside down or not.
Wait, so what?
So like, do you see what Trenton did?
Oh, yeah,
That's
yeah.
Trenton, I haven't done that for a while.
I get it.
I got it.
Okay.
I'm smart.
No, you won't. Okay, is it cool that we just took these and rearranged them?
Kind of.
Yeah.
It's totally cool. And that's what I want you to do. Now, I'm not gonna like give you scissors every time, but that's, I know. So, okay, Trent, tell me how you rearranged your example.
14x, negative 2x, negative 5x, plus 9, huh? Plus 8, plus 1. Please turn it around.
Okay, let me just. Okay. So 14x
Negative
minus
2x.
2x minus 5x plus 9 plus 8 plus 1. Okay, so that is how Trent rearranged his 6 terms. Okay, so now you can see I have my 3 variable terms together, and I have my 3 constant terms together. Now at this point, this is what's going to happen. We are going to combine our x's together, and we are going to combine our constants together. So let's talk about how we do 14x minus 2x minus 5x. Jada, how do we do it? Okay. Okay, we're literally going to add the coefficients together and keep it with x. Now, if you don't love subtraction, okay, you can change this to 14x plus a negative 2x plus a negative 5x. It is the same thing, okay? So Jada said that 14x minus 2x is 12x. Do you agree? 12x minus 5x is?
7x.
Okay, so we have 7x. And then we have 9 plus 8 plus 1. Okay, so we're gonna do a few examples here. Let's go to number 11. Go ahead and take a moment and box and circle. Did you just say there's nothing to circle? That's kind of nice because then that saves us some work, right? Okay, so I have 4x plus 7x. They are both variable terms. They're the same variable terms, so we can add them together. And it says 11. Do you agree that 4 plus 7 is 11? So 11x. All right. Let's make life a little bit more exciting here. Let's go to. All right, go ahead and box and circle number 13. Okay, so I'm going to rearrange this just like we did with our green example. Let's cut it apart and rearrange it. So I'm going to put 6c plus 11c together.
17.
And then our plus 1. So Ryan is saying that 6c plus 11c would add together to be 17c. Oh, but we have nothing to add to the 1, so just plus 1.
Oh, yeah. Jordan, wait, I mean, that's over here.
Just call me Jordan.
No, it's not over here.
You totally said Jordan.
I should have said Jordan. Are we not solving it? I did not hear Jordan.
What do you see an equal sign? Then no.
Okay, I'm just making sure.
Yeah.
What? These usually says that over here.
Okay.
I'm gonna say.
How about you and your neighbor do 15?
But I did. So. No. Please, I will go. Oh, I want to spend. I can go. Whatever. Thank you. Easy. That's probably why I have more than 100%. Yeah, I wonder what it's always. I'm pretty sure our other person.
Hey, did we have to rearrange these at all? Man, we didn't even have to rearrange them. Hey, Bronson, if I take 11m minus 5m, that equals 6m? Okay, and since I don't have anything to add to that minus 13, we're just gonna bring down the minus 13. It is a 3. Yeah. Okay. So, hey, learning opportunity. If we didn't add it to something, just bring it down and it stays the same. Okay. When there's something to add it. Okay. All right, let's look at number 17. Okay, I'm gonna rearrange this to 9v minus 3v minus v plus 7. Okay. Lauren, what's 9v minus 3v? So can we just do, let's do one step at a time. What's 9v minus 3v? So 6v minus v plus 7. Let's also keep in mind that what number is technically in front of v?
1.
There's a 1. So that's a 6v minus 1v, which is our 5v. And that's plus 7, just so lonely.
I'm so sad. Me and Jada don't have PE.
No, it's like not fun
Me and Jada and
anymore.
Gracie.
I'm so sorry. Okay, number 21, not really. Number 21. You are going to do this problem, show me your answer, and I will tell you what your homework assignment is when I check it to make sure it's right.